Hey there, everyone. Welcome back to the channel. Today, we're diving into a fascinating story that combines the worlds of physics, AI, and a decade-long mathematical puzzle. It's a tale of how a Nobel Laureate and a large language model, Claude, collaborated to solve a problem that had stumped them for years. So, buckle up as we explore the incredible journey of Francesco Zamponi and Giorgio Parisi, and their groundbreaking work on jamming. First things first, what is jamming? Well, imagine a box filled with tennis balls and zero gravity. When there's only a few balls, they move freely, bouncing around like a classical gas. But as you add more balls or inflate the existing ones, space becomes scarce. Eventually, a critical density is reached, and the balls lock up, forming a rigid, disordered structure. This is what physicists call a jamming transition. Now, this concept isn't just limited to physical spheres. It's a highly general mathematical problem known as constraint satisfaction. In this framework, the positions of the spheres are variables, and the rule that no two spheres can overlap is the constraint. As more variables are introduced, satisfying all the rules simultaneously becomes increasingly difficult. This idea has wide-ranging applications, especially in neuroscience and AI. In a machine learning model or a biological brain, synaptic weights represent the variables, and data classifications or memories are the constraints. So, when an AI network is tasked with too much data, it hits a wall, just like the spheres in our jamming scenario. Fast forward to 2014, when Parisi and Zamponi stumbled upon a surprising relation in the theory of jamming. They found that two mathematical parameters, A and B, add up to 1 in numerical calculations. These parameters are crucial for understanding the physical structure of the packing, but they couldn't prove it mathematically. That's where Claude, the large language model, came into play. Parisi had the brilliant idea of asking Claude for help. The problem was well defined, with a clear conjecture and a known numerical answer but no analytical proof. Claude, with its advanced coding and mathematical reasoning capabilities, was the perfect tool for the job. They first prompted Claude to replicate their decade-old numerical calculations, and then they asked it to prove the relation A plus B equals 1. Claude delivered an initial conceptual path, but it had minor mathematical errors. However, the core intuition was there. Zamponi realized that the solution was simpler than they thought. It was right in front of them, but they had just missed it. The new proof connects their infinite-dimensional theory with a framework developed by Matthew Wiart and his team at EPFL. Now, here's where things get really interesting. Zamponi believes that generative AI like Claude could be as significant as the Industrial Revolution or the birth of the Internet. As a telescope for the mind, it could revolutionize research, allowing scientists to test ideas at unprecedented speeds. It could also lower specialization barriers and facilitate interdisciplinary work. However, Zamponi also raises a valid concern. LLMs can encourage the production of poor-quality, pseudoscientific research, straining the peer review system. We need to figure out how to filter and review this influx and design new pedagogical frameworks to integrate AI tools responsibly into research courses. Lastly, Zamponi emphasizes the importance of transparency. If an AI sparks a new idea, its thought processes should be public record. They chose to publish their full conversation with Claude alongside their paper, ensuring that the AI's contribution is acknowledged and understood. Moving on, Zamponi is now applying the same approach to a problem involving random sequential absorption, RSA, of hard hyperspheres. RSA is a classic protocol for generating random packings, helping us understand the geometry of void spaces and packing efficiency. While RSA and jamming transitions describe how systems of hard spheres lock up, they represent different physical processes. In conclusion, the collaboration between a Nobel Laureate and a large language model has not only solved a decade-old mathematical problem but has also opened up new avenues for research and understanding in physics and AI. It's a testament to the power of human-AI collaboration and the endless possibilities it holds. So, what do you think? Is this the future of scientific discovery? Let me know in the comments below. Thanks for watching, and don't forget to like and subscribe for more fascinating content. See you next time.